Hey guys, welcome back to my channel, The Math Pad, and today we're going to do surds. So we're going to do addition, subtraction of surds, multiplication, and division. So if you look at the first question, it says rationalize the denominator. So when they talk about rationalizing the denominator, basically what they're asking us to do is to get rid of the surd from the denominator. So in order to get rid of the surd from the denominator, what we do is we multiply and divide the fraction by the surd in the denominator. So basically, I'm going to multiply 12 with root 3 and root 3 with root 3. So when we do that, we have 12 root 3 over square of root 3. Now, whenever you square a square root number, the final answer is the number inside the root. So it will be 12 root 3 over 3, which is 4 root 3. Now this is the final answer, and this is a rationalized form of 12 over root 3, because now root 3 is not in the denominator, it's in the numerator. Hence it's rationalized. And if you look at 1b, it says work out the value of root 2 plus root 8 whole square. So we can rewrite root 2 plus root 8 whole square as root 2 plus root 8 times root 2 plus root 8. So we just rewrite this as the bracket being multiplied to itself, and then we expand the brackets. So root 2 gets multiplied with root 2 plus root 8, and similarly root 8 gets multiplied to root 2 plus root 8. That's going to be square of root 2 plus root 2 times root 8. Similarly, root 8 times root 2 and plus root 8 whole square. Now, root 2 times root 8 or root 8 times root 2 basically represents the same thing. And square of the root is the number itself, so it's going to be 2 plus. Now, when you're multiplying roots, we just rewrite this as a single root and times 8 by 2. So it's going to be 10 plus square root 16 plus square root 16. Why square root 16? Because 8 times 2 is 16. Now 16 is a square number because 4 square is 16. So we can rewrite root 16 as 4. And 18 is our final answer. Similarly, if you look at question number 2, it's pretty much the same thing, but now instead of the surds being added, they're being subtracted. So we rewrite root 12 minus root 3 whole square as root 12 minus root 3 times root 12 minus root 3. Going to be root 12 times root 12 minus root 3 minus root 3 times root 12 minus root 3. Root 12 whole square minus 12 times root minus root 12 times root 3. Similarly, minus root 3 times root 12 plus root 3 whole square. So square of root 12 is 12. We combine 12 and 3 in the same root. Same over here. Square of root 3 is 3. 12 plus 3 is 15. 12 times 3 is 36. Now, once again, 36 is a square number. So root of 36 is 6. So 15 minus 12, 3 0. Applying the same concept, the only difference is that in the previous question, the surds were being added, but now they're being subtracted. Question 3 is also pretty much the same as question 1. It's asking us to rationalize the denominator and give your answer in simplest form. Same thing, we're going to multiply and divide the fraction by the surd in the denominator, which is root 5. So it's going to be 10 root 5 over square of root 5, which is 10 root 5, 5, and that's 2 root 5. That is just simplified. Now, question 4 is slightly different from the previous question. It says, show that root 12 over root 3 plus root 2 can be written in the form of a root b. So what we can do is, let's add 3 plus 2. That's going to be root 5. Then we multiply the fraction by the root in the denominator, which is root 5. That's going to be 12 root of 12 times root of 5 over square of root 5. So 12 times 5 comes in the same root. Square of root 5 is 5. Root 60 over 5. Now we rationalize 60. So when you talk about rationalizing 60, basically we're going to prime factorize it. So when you prime factorize 60, what I mean is that we're going to break down 60 into its prime factors. So we know 60 is 6 times 10, 6 is 3 times 2, and 10 is 2 times 5, which means 60 can be rewritten as 3 times 2 square times 5. 3, 2, and 5 are all prime numbers, so hence they're playing the role of prime factors in this case. So inside the root, I'm going to write 3 times 2 square times 5 over 5. Now 2 square is basically 4, and 4 is a square number, so which means square root of 4 is going to be 2. So 2 comes outside, 3 and 5 remain inside the root. That's going to be root 15 over 5. So your value of a is 2 over 5, which is simplified fraction. And b is an integer, which is 15. These are the values that we get after rationalizing and simplifying this third. Now, if you look at question 5, it says show that the left-hand side equals the right-hand side. So on the left-hand side, we have 6 plus 2 root 12 whole square. We have to convert it into the terms on the right-hand side. So what I'm going to do is, I'm going to rewrite this as the bracket being multiplied to itself. I'm going to expand the bracket. So 6 times 6 plus 2 root 12 plus 2 root 12 times 6 plus 2 root 12. That's going to be 36 plus 12 root 12 plus 12 root 12 plus 4 times root 12 whole square. Okay. So we can do 36 plus 24 root 12. Now, when it comes to adding or subtracting surds, you need to remember that when you're adding surds or subtracting them, the number inside the root sign has to be the same. If it's not the same, then we cannot add or subtract it. In this case, since inside the root it was 12 for both 12 root 12 and 12 root 12, hence I can add them, and I did add them and turn it into 24 root 12. Over it is going to be 4 times 12. Which is going to be 48. So I'm going to add the 36 and 48. It's going to give us 84 plus 24 root 12. Now the thing is, we can simplify root 12. 12 is basically 3 times 4, and 4 is 2 times 2, which means 12 is 3 times 2 square. So 84 plus 24 times 3 times 2 square. 2 is being squared, so we can bring it outside, and it gets multiplied with 24. That's going to be 84 plus 48 root 3. That is your completely fully simplified answer for this question. Now over here, they were taking 12 common. Oh yeah, so we can rewrite this very easily. If we take 12 common, it's going to be 7 plus 4 root 3. Yeah, so it's the same thing.